So, welcome back to this lecture. We will discuss one of the very important and burning issue, that is actually biomass burning that happens in India, and especially it gives lots of trouble and high air pollution in the Indo-Gangetic plain. So, continuing from the previous lectures where we discussed about the primary sources of aerosols, this is actually we are now discussing that what are this one of the very important primary emission sources, like biomass burning is contributing to the air pollution in the Gangetic plain. Okay. So, this we discussed in the last lecture itself, that these are the factors that affect the air pollution in the at any location. Actually, it is not very specific to the Indo-Gangetic plain or India. This is actually this is applicable to all over the globe, across the globe. Okay. So, one of the things is actually like emission, of course. So, if you have that depends actually, and we will try to calculate that what is the total emission that is coming from the particular emission source. So, for example, traffic, industrial and domestic, we will calculate that one. So, there will be some terms like emission factors, then combustion efficiency, something like that. There will be many terms that will be coming in that one. So, we will discuss that one, but let us first discuss that what are the actually prominent issues, that there will be some mathematical calculations and that we can do later actually. Okay. So, then the next thing is actually the geography, the geography or terrain of the particular location or the sampling site, or on a regional scale if you talk about, or the country as a whole. Okay. Then the weather conditions, rain, wind, humidity, these are the three very important issues, and if you just add here sun solar radiation, and here we actually talk about mostly the photochemical reactions that actually happens here. This can actually cause kind of secondary organic aerosol, secondary aerosol. Let us not say secondary organic itself, let us say secondary aerosols. So, this formation happens with this one, and that contributes again enormously to kind of air pollution over the location. So, solar radiation should also be considered in that one, and then we have actually season. What is the season during the particular period? So, in India actually like different places they have different kind of seasons. In India we have 4 seasons, and we will see that actually like we usually talk about summer and winter. They are the 2 main seasons. Then in between you have monsoon season, and just between this monsoon and this we usually call it pre-monsoon, or sometimes it is also called as spring season. So, these are the 4 seasons that we usually consider in India. There are actually and if you go other countries, like they have autumn, spring and then other things. So, in India we have only 4 seasons that we generally consider. Okay. Then we talk about the diurnal variability, and this becomes very important especially for the short-lived species. So, whether they are in the gaseous form or they are in the particulate form, this becomes very important, and if they are gaseous form, then the second most important is that what is the reaction that is happening there. So, and then how it is converted to the particulate form. So, this is also very important. So, in a way this also contributes to the air pollution, and then we can calculate. For example, if I give the example of SO2 getting converted to sulfate, then you have nitrate NO2 getting converted to nitrate radical. It is not very easy process. For your kind information, these processes are very different, and we will probably have some time, we will discuss the chemical reactions that are involved here, but let us not go in details right now. Okay. Then I also discussed about the population density. So, air pollution is actually kind of is a function of population density. If there are more people living in the area, then basically because they need food, they need electricity, they need transport, okay, and they need job. So, all these will contribute to the pollution in a specific locations. So, this is one of the reasons that especially in metro cities in India, they are highly polluted compared to the non-metro cities or urban area or rural areas. So, rural areas we generally do not have. Then in the last we have outdoor or indoor pollution. This becomes very important, and in India we discuss lots about the outdoor air pollution, but there are very little information on the indoor air pollution, and I think there must be a very serious discussion about this topic actually, because this when we will discuss the exposure, so kindly note that exposure is actually a function of not only the concentration, but that how much time do you spend there. So, indoor environment we spend more time, because suppose you are working in an office, in a particular office you might be putting lots of time there. So, 8 hours job is for example there, or sometimes you do overtime. So, you are working for 10 hours, 12 hours or whatever time you are working. So, even though the concentrations there are low, this concentration is low, but you have putting lots of time there. So, energy of time. So, if you multiply the concentration, the exposure might be actually very high. And then not only that, the other very important thing is actually composition, because the composition is also very important. So, the composition here might be very different than the composition that you have in the kind of outdoor environment. So, indoor and outdoor compositions are very different, and therefore, their exposure and their health impacts, they should be discussed. Their health impact, they should be discussed separately actually. So, they should not be clubbed, but this is all that we need to know. So, the one question that might be actually intriguing you, that why there is so much pollution in the Indo-Gangetic plain itself. Okay. So, I gave the lots of reasons. This lecture is again just brushing up the last lecture's things. So, just few slides you will be having. Some of the things that will not covered, I will be putting this one. So, I discussed about this Indo-Gangetic plain. We discussed about this Indo-Gangetic plain and why this pollution is there. In high pollution we have here, and then you have a pocket, sorry, this is actually pocket here in Bay of Bengal. This we already discussed, and I discussed the mechanism as well actually. So, this becomes very important. Meteorology obviously plays a very important role, and that is why if you see the regions like coastal areas, they are not actually having high pollution. Here even you have here, and then here you have like even go to Ahmedabad, but these are the regions where you have lots of kind of what you call dust. So, dust aerosols are very high there. So, that might be also impacting actually, that impact actually, but that kind of impacts. And not only that, this dust actually from the western India, this is transported and then it is again polluting to the Gangetic plain. So, transport pattern we will be discussing. So, this is actually I said that kind of not only the emission that is present in the Gangetic plain, the sources that are here, they are actually getting top up of that one, that natural as well as anthropogenic aerosols are transported, and they are giving huge kind of air pollution in the Gangetic plain. Okay. I give a very clear example here. Now, how the transport pattern, in the previous slides I just gave the example of the westerlies, but if you just give an example of this one, you see this slide. This slide that actually talks about that changes in the PM 2 concentration when the transport pattern itself changes. So, this is very important. This location was actually we collected the samples at Varanasi. Now, what is happening? If you see this all the way, these are actually coming from the air mass. If this is actually plotted, is actually air mass back trajectory, 5 days back trajectory that is plotted here. So, if you see that the actually in this 5 days earlier, the air mass was here and this was moving like in this direction, and this actually reached here. So, Varanasi, it did not enter most of the polluted sites here, though. So, the western India or Punjab and other places. So, this is actually also very important. The timing is also very important. So, if it happens during the summer season or winter season, you have to keep in actually. But this was done actually with the just 2 weeks of sampling we did, and we wanted to know that how the concentrations are varying here. So, when the winds are coming from, or the wind pattern is not from the source regions or polluted regions, usually we have very low concentration. You see one air mass is coming from the Bay of Bengal. So Bay of Bengal is usually cleaner, it doesn't have much of the pollution source here. So you don't have much of the pollution that is added. And then the third part that is coming from the central India. So this central India part is actually bringing some air masses, but it is not putting lots of aerosols here, because here you again don't have much sources, but of course this contributes to significantly. It has some sources here on the way. So this becomes very important when we have a very concentration of PM 2.5, which was like less than 60 microgram per cubic meter. So this during this week we had very low concentration, but if you see here the same picture, but you see the winds now, this almost like 53% of the winds are actually coming from the much of the polluted areas in the western India. So it is not passing, the winds is actually just in the you can say in the tips of the in the valley of the Himalayas. So in the valley of the Himalayas they are bringing lots of pollution from the upwind sources. And of course we have here like what you call wind was my trajectory again from Bay of Bengal and then central India. But if you see the contribution, this is contributing about 50%, 55% or so, if I can just read the number carefully, while in the other cases it was only, the winds was like only 8%, 7%. So majority of the winds, they were coming from the polluted regions and they bring lots of aerosols. So just at a simple location, at a single location, just because change in the pattern, wind pattern, this can affect. And this is how you can, we need to understand that one, and this becomes very important, because policy making is not only measuring the concentration, it's also is important that how these are actually varying. So if you know that actually this pollution, this wind is actually, for example, coming during the second case, suppose we know that priorly that wind will be mostly, say in this month the winds will be from the western part of India, then there could be one of the option that okay, you request them or you make a guideline that you put the all the emission sources that are there, you just cut off the sources there will be no emission from there, and then they are transported. Then once they are transported, they can actually bring less aerosol compared to compared to when we have actually like high pollution days. So this is kind of intervention or policy intervention are needed actually. So now we are discussing that how it can be. For example, there will be always a blame game between Delhi, Haryana, and then political as well as actually that okay, Delhi's air pollution is contributed by the neighboring states like Haryana and Punjab during this period. So yeah, it's true to some extent, it does contribute, but whether it is contributing that much only biomass burning, it's not actually correct. It is not very easy to say that okay, it's only the biomass burning that is contributing or agriculture based burning is contributing. So the factors we have to understand that all the factors we have to understand. For example, one of the things is like when you have this just during this period the winds will be slow, wind speed will be slow down, then you have a temperature also becomes lower, and then what is same thing, temperature is also lower, as well as your total emission is increasing, and you have additional source. Okay, so you have an additional source of agriculture based burning that is increasing actually. For example, just talk about the Delhi case or something like that. So wind speed is lower, temperature is lower, emission is increasing, and if you just take boundary layer height, this boundary layer height. So if you just talk about the boundary layer height, this also becomes less. So now all the things, all the meteorological factors that were responsible for dilution of aerosols, they are actually reduced. So wind speed is reduced, temperature is reduced, boundary layer height is reduced. In contrary, the emission is increased. So if the emission is increased, what will happen? This will actually all the way it has to contribute that one somehow. So emission is increased. When the emission increased, you can't do anything, right? This cannot be controlled by the what you call meteorology actually. So meteorology will be playing a role, but it does not actually seems to be the case here, because all the other meteorological conditions are unfavorable, and they leads to accumulation of aerosols rather than the dispersal of aerosol. So, this becomes very important. Now, when you have to consider this one, how you have to do. So, meteorology specifically, if in this case, for example, in China, I visited there in Beijing for a few months there, and I learned there that when there will be a very high levels of air pollution in the Beijing, I was staying in the Beijing. So, in the Beijing there will be huge winds blown from the other parts. So, these winds will take away all the aerosols or the pollution from the window from the Beijing areas to the other, and this will be actually kind of dispersion. That is one thing. Then the other thing is actually like artificial rain, but that is also a very big issue. We will discuss those things in mitigation policies when we will discuss. And then I talk about the emission. Of course, I told that emissions becomes very important, and in the previous slide. So, you can see here that the contribution from different sources. This is water soluble inorganic species, means all the ions are soluble. This is total carbonaceous aerosols, which is taken as actually, just remember this one, I just gave you concept of OC and EC. Just remember that this TCA is actually 1.6 into OC plus EC. So, just remember this concept that TCA is actually. So, now you see what you see here, there is during the, as you move from, although we don't have a spring season, but we just called actually just after the February months, February and March, we just defined it as a spring actually. Many people actually pre-monsoon will be like summer season, it will be called pre-monsoon, or you can define what, but mostly in the India we have just 4 seasons as I discussed. So, you see in the winter season what is happening, the TCA is keep on decreasing, it is in a decreasing mode. Then you have TCA that is also decreasing. So, and then you see this concentration PM10, PM10 also in decreasing. So, this is you see the period. What is the period? It is the first sample that is collected is actually in 17th. This means this is actually January. So, January sample are collected. So, from January as you move from January to February, the emission sources are getting lower. This you see here, TCA is getting lower, as well as so. Emission sources are reduced, and then not only that, the boundary layer height also starts increasing in this period, because the temperature, it's how the boundary layer will evolve. It will, if you heat the way boundary layer will evolve, if you heat the surface, the heat will take the will heat up the air that is lying lower in the lower atmosphere, and it will be actually going up, and when this is going up, this will be a kind of boundary layer, and the height that will be decided. Okay. So, if you don't heat that surface, what will happen? The wind will be cooler, and then cooler wind actually will not go up, it will not rise. So, it is not rise because of it has high density. So, it has humidity. So, it will not rise. It will not rise. What will happen? The the cellular layer, the boundary layer height will be lower. But when the surface is heated, it will heat the surface, and then it will take lots of air mass that is in the close to the surface and to the upper to the height in the upper troposphere, or say height up to say 1 kilometer, 1.5 kilometer, 2 kilometers, whatever the height it can go actually. So, this becomes very important. Okay. And then you see in the summer season what is happening. Summer season is almost like contribution remains almost like similar, not too much variation, and I will give you the reason, because during summer season the main contribution becomes from the dust actually. So, in the next slide we will see that one, and this is very important here. You see what is happening here, 162, it is actually like May or June, just starting of the June, end of the May and June, you see the aerosol starts build up. So, this period is actually you get lots of dust here. Okay. And then you increase the PM10 concentration also is increasing, but TCA is also slightly increasing, and then you have like increase in the WSIS as well. So, post monsoon, sorry, this is I am giving wrong interpretation here. So, it is actually pre monsoon actually 162, after 162. So, we have only 274. So, this is actually not May June, this is October November. Okay. So, October November, like the currently we have actually in the November. So, you see that October months, at the start of the October, the TCA TCH actually means this is burning of the unburnt hydrocarbons that are removed, and unburnt incomplete combustion of fuels. This will give actually carbonaceous aerosols, which is increasing here, and then the water soluble ionic species is also increasing. So, this you can see very clearly from these two pictures. Yeah, so I was talking about this one. You see this picture. This is actually the composition. In the summer you have like actually 190 microgram per cubic meter during the winter season, December to February you can say, and when you go, the concentration is not much varying, which is actually like 150 compared to 150 190. But what you see here you have mostly dominated by the carbonaceous aerosols, about 35% here, and then 3% is actually like black carbon, but this 35% is reduced to only 15%, and the 15%, and then you have actually like increase in the dust. So, that dust becomes like 73% or 75% here, and then you have only 35% or 40% here. So, this becomes, so this April, May, June, this contribution becomes very important. You have huge contribution from the dust. So, this is very important here. We will discuss this one. These are some scientific topics, you can talk about that how much it is contributing, and then we will discuss this one. So, just to bring the concept of crop residue burning, there are lots of papers that came into that crop residue burning in northern India is increasing threat to the greater India, then crop residue burning a threat to the South Asian air quality, increasing health threat to great parts of the India due to crop residue burning. Lots of papers came into this, and then lots of discussion happens on this one, that how they are contributing, and this is what happens. What you see, this is usually you have two seasons of burning. One season that actually happens in the April and May. So, here we most of the time wheat, and there you have a rice kind of paddy burning. Okay. So, in the wheat you can see what you see here, the wheat burning intensity is low compared to the rice burning intensity. So, here the intensity is higher. So, what is happening here? Now just compare these two things here. Intensity is also low, and here the intensity is higher. But what is happening apart from the intensity? What is happening? The second thing that is happening here, in the winter months, sorry, where it is pointer. So, in the summer months, what you have? Summer months you don't, emission is actually reduced. You don't have emissions. Of course, emission is, sorry, the emission is there actually. So, what is happening here? In the summer seasons, your boundary layer height is actually up, your wind speed is up. Okay, and you have the of course you have an additional source of aerosols, additional source of pollution you have here compared to this one, but the wind speed and then this boundary layer height is so much varying that they are actually almost like will be contributing very less to the pollution. In contrast, if you see here, what is happening here? During winter season or rice season, October, November is the time period where we cut the rice actually, right? What we harvest the rice. So, what will happen? Wind speed is already reduced, boundary layer starts to reduce, and then you have actually like you have no less ventilation, and then of course temperature is becoming low, and this all contributes, and then of course what is there? Emission is already increased. So, this contributes to the high air pollution this period. So, if you are asked that why there is a huge problem of crop residue burning is winter season compared to the summer season, you can very easily understand with this concept. This concept is really very important, and if you please, this is very important, please study these things actually. And not only that, if you see this one, if you just burn wheat straw, okay, if you burn wheat straw, it can be burned very easily, and it will be giving less particulate matter or black carbon or carbonaceous aerosols. Okay. But if you because this is why this is because this is dry, okay, and if you compare this one, the rice is actually cut. When it is cut, actually the paddy is actually already is not completely this, so it is already moist. Okay, so it has water in it. So, if you burn anything that is actually having water, it is not completely dried. So, the combustion will be inefficient, it will not be completely burned. And then the same thing if you talk about the characteristics difference between the wheat and straw, these are different. So, these two the composition of the fuel that we are using actually they are different. So, when the composition of the fuel is different, then the burning or the I gave the concept of combustion efficiency, okay, and combustion efficiency is very much important and depends on the types of fuels. So, this will be actually very important. So, types of fuels, we have different types of fuel. One is very susceptible to burning, gives less of particulate matter, emits less of emission particulate matter, whereas other one has in, and this is just because of the composition of the fuel that we have. Then if you see this is the period, okay, and people are trying lots of things were happening. This is the area where lots of patches are there. You have already have very this is actually fire counts. So, this is fire counts that were detected during the 30th October to 7 November 2016. 2016 was one of the very biggest pollution Delhi 2016 was actually like Delhi pollution becomes very significant, and it was very in the news everywhere, almost not only what was covered in the India, it was also covered abroad. Okay. So, during this period what happened, just see that during 13 to 7th November this region has a huge kind of biomass burning here, agriculture waste burning, and the wind mass also passes through this one, and this brings lots of aerosols to this region. So, yes, during this period yes the contribution is here, but now you imagine a situation during just few days back, just a week back actually, not few days back only, just few days a week back, 21 to October to 29 October, there were less actually fire counts, and winds were still coming from that side, right. So, winds were still coming. Of course, the winds were coming from this side, and then majority of the winds were from here. So, they did not pass through this one. So, polluted region. So, this region actually did not had very high pollution, but still this contribution of the pollution was very high here. So, you can imagine the situation if the wind pattern passes through the source region or over the source region, you will be having more of pollution. If it is coming from the cleaner areas, you will be having less pollution. So, not only the emission sources or emission kind of the type of fuel that you are using, emission change in the wind pattern itself can affect the kind of what you call emission air pollution at a given area. So, I thank you here, and if you have any questions you can of course write and discuss with me. So, I am available on phone or or email. And I think in the next lecture what we will discuss, that we will discuss about the types of fuels, how they are actually used, and then we will talk another very important pertinent issues, that whether the crop residue burning is the only culprit for the Delhi air pollution, and what are the solution for this one. So, we will discuss this one. We will discuss actually type of fuels, and then how they are actually like combustion efficiency we will discuss other things that are related, and then we will finish this one primary emission or primary organic aerosol composition. We will finish from here, and then we will move to the next section. So, thank you, bye bye so far, take care.